This is the screencast for example 4 of section 4.8. We're going to use some trig in navigation. We did this earlier in chapter 4, but all we had to do was set up the plot of navigation. Now we're going to calculate some distances and some bearings or degrees, of course. A U.S. Coast Guard patrol boat leaves Port Cleveland at and averages 35 knots or nautical miles per hour, traveling for 2 hours on a course of 53 degrees, and then 3 hours on a course of 143 degrees. What is the boat's bearing and distance from Port Cleveland? Well, first of all, let's talk about nautical miles. Nautical miles are, it's hard to measure a distance on water, so I actually Wikipedia'd nautical mile, and it says the nautical mile is a unit of length that's about 1 minute of arc, and we know that 1 minute is 1/60th of a degree. It's of latitude measured along a meridian, or 1 minute of arc of longitude around the equator. So by international agreement, again, really difficult to measure distance on water. Roads are made flat. Water cannot be made flat. It's always curved. So by international agreement, it's exactly 1,852 meters, or about 6,076 feet, which is a little bit more than a linear mile. Back to our problem. So what I've done here is I've drawn this course. So first the boat goes 53 degrees and then turns to 143 degrees course. So what I did was opposite internal angles are of two parallel lines, which would be the northbound line here that I drew. They are supplementary. So this angle here is 127 degrees. This angle here is 143 degrees. So to find this one, we can take 360 degrees minus 143 minus 127, and we'll get that that is 90 degrees. So fortunately for us, this is a 90-degree angle, and we can use right triangle trigonometry. Now the other part of this is I called P the port, T the spot where the boat turns, and B where the actual boat is. So to find the distance of PT, distance equals rate times time, just like linear miles or distance. So PT, this distance, equals the boat's rate, 35 nautical miles an hour, times how much time? 2 hours. So that's going to be about 70 nautical miles. Then TB is going to be the rate the boat was traveling, still the same speed, 35 nautical miles an hour, but now for 3 hours. So that's going to be 105 nautical miles. Now I can use Pythagorean theorem to find out what this length is. So that x is the hypotenuse, the distance from the boat to the port. So I can say 70 squared plus 105 squared equals x squared. X squared is, we'll just say x equals square root of 70 squared plus 105 squared, which in my calculator is about 126.19 nautical miles. Now, the instructions also ask us for the bearing from Port Cleveland. So in other words, if the bearing is the bearing if leaving Port Cleveland. Bearing from Port Cleveland is like if that boat just headed to the spot it was at now, what angle would that be? Well, that's going to be 53 degrees plus this little angle inside of our triangle. So that's going to be 53 degrees plus, now to find an angle, we all know we can use inverse trig. So I'm going to take, let's see, I know 105 and 70, and those are very easy numbers. They're not, I didn't have to round or use a number in my calculator. So I'm going to use this angle's opposite and adjacent. So I'm going to take the inverse tangent of 105 over 70. I'm going to make sure I'm in degree mode. When I put that in my calculator, I get 53.98 degrees. So what this problem is saying is if the boat left right from the port at a bearing of 53.98 degrees, it would have ended up in the same spot it is now after 5 hours, after actually a shorter amount of time than if it would have gone a little bit further north for 2 hours and then back down south a little bit for 3 hours. Now number 17, the now try problem, same kind of setup. I have called C Corpus Christi, I have called T the point where the boat turns, and B where the boat is now. It says the Coast Guard cutter Angelica travels at 30 knots from its home port of Corpus Christi on a course of 95 degrees for 2 hours, and then changes to a course of 185 degrees for 2 hours. Find the distance and the bearing from Corpus Christi port to the boat. Well, if this boat is traveling at the same speed for 2 hours on one leg of the trip, and then the same speed in another leg of the trip for 2 hours, those distances are actually going to be the same. But just for good practice, I'll say CT from Corpus Christi to the turn was rate 30 nautical miles an hour for 2 hours, 60. And then from TB, 30 nautical miles an hour, again for 2 hours, 60. So this is 60, and this is 60. No, actually we're just going to use Pythagorean theorem. So x squared, the hypotenuse, equals 60 squared plus 60 squared. So x is going to be whatever the square root of 60 squared plus 60 squared is. And in my calculator, I got about 84.85 nautical miles. Then the bearing from C, which is Corpus Christi. If you remember from back in geometry, this is a right isosceles triangle. So since this is a 90-degree angle, we have 45-degree angles each here. So the bearing from Corpus Christi is 95 degrees plus that 45 degrees, which is a total of 140 degrees.